Coordinates by Aidan Donovan, Kai Gowers, and Kyle Chu. History of polar coordinates. The concepts of angle and radius date back to the first millennium BC. Hipparchus, a Greek astronomer, was able to create a table of chord functions where he gave each angle a length of chord similar to polar functions. A Greek mathematician named Archimedes created the Archimedean spiral, which was a function that had a radius depending on the angle. In the 17th century, Gregor de Saint Vincent and Bonaventura Cavalry first introduced the idea of polar coordinates. Blaise Pascal, a French mathematician, was able to use this idea of polar coordinates to calculate the length of parabolic arcs. Isaac Newton explored transformations between polar coordinates and other coordinate systems. The term polar coordinates was first created by Gregorio Fontana in the 18th century. Alexis Clairaut was the first person to use polar coordinates in 3 dimensions. Leonhard Euler was essential in developing polar coordinates.
Okay, I'm gonna go over the real life connections of polar coordinates. So to start off, polar coordinates are used to calculate the equations of motion in mechanical systems, and it can also help when trying to find the pattern of which objects that move in circles. And then sounds often mimic patterns which are represented by polar coordinates. And it can also be used in navigation, such as map projections. And then you can also draw using polar coordinates and create quite fantastic shapes. And then once again, polar coordinates are used with sounds such as a microphone, where they measure the sensitivity of sounds caught by a microphone. And then lastly, radar uses polar coordinates, which is still used today.
Euler's formula states that for every real number x, e to the ix is equal to cosine x plus I sine. It allows you to write complex numbers in exponential form. Z is equal to x plus iy, which is equal to r cosine plus I cosine theta, I sine theta, which is equal to r times e to the I theta, equal to x squared plus square root of x squared plus y squared, and e is Euler's number. For real numbers, add the angle. E to the I theta sub 1 times e to the I theta sub 2 is equal to e times theta sub 1 plus theta sub 2. For complex numbers, multiply the absolute values and add the angle. R sub times e to the I theta sub 1 times r sub 2 times e to the I theta sub 2 is equal to r sub 1 times r sub 2 times e to the I theta sub 1 plus theta sub. The reciprocal rule is 1 divided by to the I theta is equal to 1 divided by r times e to negative I. The division rule is r sub 1 e to the I theta sub divided by sub 2 e to the I theta sub 2 is equal to r sub 1 divided by r sub 2 times e to the I times theta sub 1 minus theta sub 2.
Okay, so for our product, we decided to make a program that converts between polar coordinates and rectangular coordinates. I'm gonna display that real quick. So this is the product. Well, what you basically can do is you enter any coordinate that you want, either in rectangular form or polar form. And if you decide to put it in polar form, it has to be in degrees. Theta has to be in degrees. So let's say you want to convert 60, 60 into polar form. You click convert to polar, and then it will give a graph of the polar yeah, it'll give a graph of the polar coordinate system, and it will display the point on the graph, and it also shows what the point is in rectangular form. I mean in polar form. So since this is the rectangular form, this would be the polar form, and it displays it on the polar graph like this. And this is all on the scale of 150. So it has a max range of 150 in every direction. Likewise, you can enter -7r and then put 60 degrees, and you can convert this to rectangular form, and then yeah, and then it displays the point on the rectangular form, on the rectangular Cartesian graph like this, and it displays the point. Once again, this is on the scale of 150. Keep that in mind, so it will be very close to the center. And yeah, that's basically the product. So I'll link it if anyone wants to play around with it. Yeah, thank you for watching.